Before we get into it, let's highlight Subnet 54 in the Bittensor ecosystem. Banks and financial institutions are required by regulators to rigorously test their fraud and AML systems. And independent testing isn't just a box to check. It's a foundational pillar to every robust AML program. Globally, billions are spent each year on financial crime prevention, yet weak AML programs have still led to more than $321 billion in fines over the past 15 years. Traditional manual testing is slow, costly, and prone to human error. But Yanez AI-powered Subnet 54 changes the game by automating AML systems testing with unmatched speed, accuracy, and scale. Subnet 54 is uniquely positioned to disrupt the industry, and with sticky multi-year contracts already secured with global financial organizations, the momentum is undeniable. There will be a link in the description for you to learn more. Let's get into it.
I find that now people ask me like what I do. Like I don't really say I do research. I say I do engineering. And I know that sounds silly, but you find that the best people within the Bittensor ecosystem, in my opinion, are engineers first and researchers like as a second thing, because it's like when you see the hunger of subnet developers and of miners, and it's pure in computation, they don't need to, understand what a rank stabilized law is. They just know if I turn this one up, it works better, and why does it matter? And it's when you're trying to solve a problem, do you need to know everything about the ins and outs? Of course, there's some space in that. There's some value in it. And I don't want to say like research is dead, and it's not, it's super important. It's just for me, like found this newfound appreciation for the builders, and like, if we were hiring, a new dev to join, I would hire someone that has built a load of stuff way over someone who's published loads of papers. Even though when I started this journey, I would have gone the other way. With people with PhDs, we're very important, and we don't, we focus on one particular area and we've allowed to explore ideas, and that's great. We have some value, but I think the real value is in people that build stuff and that can ship it and that think about edge cases, and like that I value that skill a lot as a result of Bittensor.
Yeah. And this comes from a man that got a paper accepted to NeurIPS, which is like the most prestigious AI conference. And then you're a reviewer for them as well.
Yeah. Yeah. I mean, even, I don't know, it is important. And like sharing research, and obviously some of the best work that has ever come out of AI has been published in NeurIPS, has been published in ICML, has been published in these places. But we kind of in the field noticed that there's kind of been a bit of a problem, that we've had like an exponential growth in interest in AI. Loads and loads of people are jumping into the space, which is great, but there's only a very small pool of reviewers and of quote unquote experts. And of those experts, how many have actually worked in LLMs? How many have worked in this space? It's kind of, I think that there's kind of been a bit of a problem with the review process with AI and stuff like that. So yes, all those things are good and they're great medals. I get to call up my mum and go, yeah, I'm a reviewer for NeurIPS, and that sounds super important. And it is, like, I really take pride and value in doing those things, but I don't think they translate that well into the real world, is basically what I'm saying. Like they are value, they're like a little bit of a sticker, but I think like I'm more proud of what we built with Gradients by a long, long way. Don't get me wrong, I love my PhD work. It was cool. Like I really enjoyed it. We did some really amazing stuff. So glad I got to go to NeurIPS and experience that. But I'd pick working in Bittensor and actually working on decentralized AI any day of the week, because it's real, it's fun, it moves way faster.
Do you think the speed difference is because the PhD world, the traditional world, values more like changes that are closer to the norm rather than like drastic changes?
I think, I don't think that's the case. I think actually, research community does really value drastic changes. It's just the problem with trying to persuade everyone that this drastic change is of value is very, very difficult and takes a really long period of time, because you can't just say, this optimizer you've done is no good, we should use this one. You have to then test it out on LLMs, vision, object detection, you know what I mean? Like, and then have some sort of theoretical framework as to why it's a thing. I remember, like, during my PhD, I spent maybe 2 years trying to publish that NeurIPS paper. 2 years of my life just for one paper, and the work hadn't changed. At the point of like getting the work done was maybe 3 months in, and then I spent 18 months rewriting the paper over and over and over. And there's value in that. I don't want to, communicating science is a skill that I learned, and it took a long time. But in the Bittensor world, like after the 3 months and you got the thing and it worked, it would have been out there. It wouldn't have taken another 18 months to kind of persuade people that it has value. You would have seen the value through, how did miners perform? What's the translation to in real world results with customers, things like that. So I think the speed, the speed is definitely different, but the attempt at innovation, I think, is probably the same. It's just that the speed is like you're held back by rigor, and rigor is important in some spaces. But is it that important? For real world, I'm not sure. Test in prod seems to work for most of the subnets in some way.
Test and prod is very popular in Bittensor. Let's get into your subnet now. Gradients. Subnet 56. Let's start high level. What are the minors, validators? What's the dynamic there? I know you recently have a change, but what's the legacy system first?
Yeah, so legacy system is essentially you have pre-trained networks. You have networks that have already learned language, and so they understand the semantics of basic English or basic Chinese or whatever it is. But then there's that other layer that comes later, which is, okay, great, you know language, but can you answer questions on stuff that I care about? Can you understand my product database? Can you act like Donald Trump? Can you, whatever it is, like there is a level of specialization that needs to come after that. And so all of the chatbots that people use, they are not just the basic pre-trained network. They have like instruct training and reward function training that comes after. Gradients is that bit. So we essentially take something that has a base, so we don't have to spend years and years and trillions of tokens in order to get it to understand language, which is a thing that takes a lot of time. Gradients is then, right, given that model, give me any data set in the world, as long as it has some reasonable format. And gradients will say to miners, hey, listen, miners, here's the data set, here's the model, here's how long you've got to train on it. Go get me the best trained model that is still of the same architecture, starts from that point and understands this data better than any other of the miners models that has been given the same task. And so that encompasses pretty much all of Hugging Face, or it does encompass all of Hugging Face. We started off with just instruct, which is like question answer. We then added DPO, which is like a reasonably more recent technique that says if humans prefer certain answers over others, basically. And we say to the model, hey, listen, I want you to more likely produce this answer than that answer. There's lots of data sets that are like this. And then finally, there's this GRPO, which is to say, I've got some reward functions. So here's some input text, and I want you to produce an output Y, and I'm going to give you more points for this kind of Y than that kind of Y. And so there's all kinds of different reward functions, all different kinds of data sets for DPO, and there's infinite number of data sets for instruct, and gradients covers all of those. And miners are essentially taking this data set model, time period pair, spitting out a model at the end of it. We also have diffusion, which is here's a base image model, and I want you to tune it given a few photos or a few pictures so that it produces more of a particular style. So we could have like Donald Trump funny photos that are cartoons. And if you train on, say, 10 photos of Donald Trump that are funny, this thing will just keep spitting those out. And miners have to go and get as close as possible to a ground truth of that. And what validators are doing, or the validator is doing, is essentially saying, okay, well, I'm going to keep some of this data from the training set that you don't know about, and I'm going to test you on that. I'm also going to test you on a little bit of the training data to make sure you've actually trained on it. And I'm also going to test you a little bit on some synthetic data, which is produced from the original data distribution. So in other words, it's going to be very similar to the data, but not exactly the same. And it's impossible that you've ever seen this because we are producing it in real time. And so we take is your worst loss out of those three compared to the worst loss of another -3 and a worst loss of another -3. And we do that. It's usually between 6 and 8 miners are given a particular task, and they sort of fight it out to see who can produce the best model in the time period. And they're free to do whatever they want. That's one of the things that when we started Gradients, there was a little bit of not a pushback, but kind of let's see about that with the community thinking, we were kind of one of the first subnets that said, look, we're not going to even there's no constraint here. You do whatever, it's not that you have to run with these parameters and we're going to check that you've ran those parameters or that you've ran this, this temperature or anything like that. It's just a case of you just give us the best model for that data, that model and that time period.
And then so the flow is you have a model that you want to instruct, fine tune, DPO, GPRO, you want to do whatever. You give it to a group of miners, and then the miner that produces the best model of that group gets all the reward, correct?
Correct. That's it. In that particular task, yeah. And then what we do is we aggregate rewards over time periods. So, and we split it by task type. So you could be a purely instruct miner. I only do instruct tasks. And if you did really well for a day, you'd get X amount of emission. If you did over a day and the 3-day period, then it's even more. And if you did it over 7 days, 3 days, and 1 day, you get even more. So the max you could do is if you were consistently the best miner for 7 days on instruct tasks, you'd essentially get most of the emissions for instruct tasks. Essentially, when we were doing the like miner distribution of emissions, we said like, being frank, don't really want that much waste in the system. I'd rather attract the very best miners and pay them handsomely for coming top. We're not going to give second any, we're not going to give third any, because it's kind of, this isn't about, we want to serve, we are serving real customers, and real customers want one model. They don't want 3 models. We have 3 models because competition is good, but we're not going to pay you if you're not the thing that's going to provide the service for the customers. And we found that when we started to do that, because we started obviously not like that, because you have to kind of bring miners in, but when we started to do that, we got lots of complaints. But the performance of the top miners it moved so fast. It went from a case of everyone was using LoRa and like these low ranks. Suddenly everyone was fine tuning the full model. There was a huge change when you move to winner takes all. You force the best behavior, I think, for miners, as upsetting as it can be for those that like to kind of cruise and use base code or something,
And then how important is being non-deterministic in terms of allowing miners the freedom to innovate there, important to like the result of getting that exponential improvement?
I think it would be impossible not to, because whereas for pre-training, so pre-training is like learning language, this kind of like longer task, which a few of the subnets are working on that. I think in that case, it's a relatively restrictive task, in the sense of like different sets of data should probably use the same parameters. There might be some differences there, but not huge, because you're kind of just taking a massive corpus and you're just randomly sampling it, you're just giving it. But in our case, it's like they're different model sizes. There are different data set sizes, types, entropy values of the outputs. Like there's so much variation there. Who am I to go and say, miners, we should be using this parameters? I have no idea. I could do it for one data set. I could sit and if I spent an entire day, people would pay me before this to spend, entire day just trying to find hyperparameters for one particular model, and I charge them a reasonable amount and go on with my day. So the idea that I would be able to do that for all data sets on Hugging Face, no, that's miner's job. That's the game, right? And that's the other thing that it's quite good about having this miner pool, is that even though winner takes all, we still do need more than one miner. Because some miners might be really, really good at small models or big models or whatever it is, or these types of data sets, and their hyperparameters might work amazing for that. But there's this other set of tasks that maybe they're just missing that edge case and they don't do as well. So I think that we need the variability, and we definitely can't be telling them what hyperparameters use, because we don't know. I mean, for me, that's the magic of decentralized AI, is when you have the search space that one entity just can't search or shouldn't search, especially if that involves bringing the latest research, if that involves like bringing some engineering techniques that maybe work for some data sets and not others. We're talking about trying to training the best models for any data set on the planet that you give it. And that could be 5,000 rows of Arabic sales, or it could be 1 million rows of reward functions for mathematical correctness. There's such a wide berth of data sets that have ever existed and are going to exist. And the idea that one set of parameters would work for all of them is madness. So that's why this subnet exists, essentially. Which is why I'm sure we'll come onto it when we compare with other centralized partners. There's no chance. They can't compete. There's no way they can come up with an algorithm as one entity or as one company. And to be honest, they're just using one set of hyperparameters, as far as I can tell, or one algorithm. And it's just not good. You can't compare the motivation structures with miners who are like, I'm going to get paid if I get this right, and I'm going to focus on this particular small segment of problems that I see that keep coming up and the market is demanding those. Like, it's just such a different game,